Okay, we're looking at problem number 1, dividing algebraic expressions, and we have to remember that when we're dividing and we have exponents, if they're the same variable, we can subtract our exponents. So we have 5 over 2 divided by 2, which is just 5 over 2 minus 2. So 5 over 2 minus 2 is 1/2, so x to the 1/2 is our simplified form. Same thing here. My like variables, I will subtract the exponents. So I have 2 minus 5 here and 4 minus 3 here. And I get m to the negative third and n to the 1. And remember that we don't want a negative exponent, so we're going to put our negative exponent in our denominator. So we just left with n over m to the third. Let's do the guided now. So the first one, y to the 3/4 divided by 1/2. So I get y to the 3/4 minus 1/2. And when I do that, I get y to the 1/4. And for those who don't remember the fraction part, I change this 1/2 to 2 over 4 by multiplying top and bottom by 2. And I get 2 over 4. And I just get 3 minus 2, which is 1 over 4. The next one, I have d to the 7 over 2 minus 3. And when I do that, again, I get d to the 7 over 2 minus 6 over 2 is the same thing as 3. And so I get d to the 1/2. For the next one, I get my like exponent, so I have k to the 6 minus 1 and j to the 2 minus 5. And so I get k to the 5 and j to the negative 3. I don't want to have a negative exponent, so I get k to the 5th over j third. Let me circle my answers. All right, the next one, I have a to the negative third minus 5 and b to the 7 minus 2. So I get a to the negative 8 and b to the 5th. Don't want negative exponents, so I have b to the 5th over a to the 8. Okay? And then the last one, I have x to the 4 minus 4, y to the negative 1 minus a negative 5, and z to the 8 minus, there's an invisible 1. Well, when I have x to the z, I get x to the 0. And then I get y to the negative 1 minus the negative 5, which is negative 1 plus 5, which is 4. And I get z to the 7. Well, x to the 0 is 1. And so I'm left with y to the 4th, z to the 7th. I hope this helps.